So in this first module, we're going to go over the concept of matrices and vectors. And I'm sure that many of you are probably thinking about just skipping on in the video now because this is content that you've likely heard before. However, the reason that we're doing it is in order to establish a mathematical basis, in order to be able to do some labs in introduction to computing, particularly with MATLAB, along with mechanical engineering. In addition, I think it's a very big misconception when individuals think about the type of math that's really important for engineering. Because when you look in your degree plan, there's so much calculus. It's tempting to think that when you actually get into the engineering workforce, that you're going to be taking derivatives all day or doing integrals all day. And while those concepts are particularly important in order to build a solid understanding of why physics works the way that it works, since physics is naturally described by partial differential equations like the wave equation, diffusion equation, and so on, and you can't understand the differential equation without understanding calculus, you do need to take the classes when you're going through your degree plan. However, from a functional point of view, there's really no kind of branch of mathematics that's more important to engineers than matrix or linear algebra. And there's lots of different reasons for that, but if you've ever heard of any kind of simulation packages that might allow you, for example, for those of you going into electrical engineering, to design an antenna using what's known as computational electromagnetics, or to given a physical structure to understand what kind of loads it can bear using a technique called finite element analysis. All of those run on the back end by using numerical methods in order to convert differential equations into a system of linear equations, which can be solved by matrix algebra, as we'll see here. In addition, if you know anything about artificial intelligence, or if you're interested in it, and you've heard the term deep learning, which involves the use of very large neural networks, the mathematics of neural networks are kind of governed by linear algebra. So this is incredibly important stuff, so be sure to stay tuned. So what is a matrix? Well, a matrix is nothing more than a collection of numbers, and mathematicians call single numbers scalars. Particularly, it's a collection of numbers that's arranged into both rows and columns. And remember that rows are just horizontal collection of numbers, and columns are vertical collections of numbers. So if you look at this kind of variable here that I'm defining as m, and by convention, typically matrices are defined using a capital letter as a variable, but that's not a hard rule. M doesn't necessarily mean matrix here. It could be any variable that I want. But this particular matrix, which I'm calling m, I'm defining it as a collection of scalars. And if we look, we can either view it as being arranged as 1, 2, columns, right? Remember that columns are vertical collections of numbers, or 1, 2 rows. So this matrix could be described by its size, which is 2 rows. When we number, we start in the upper left-hand corner, row 1, row 2, by 2 columns, column 1, column 2. So we would refer to this as a 2 by 2 matrix. That's how you actually say the kind of cross or X that's in between the dimensions here. And traditionally, when people are describing the sizes of matrices, they call the number of rows m and the number of columns n. Now, one of the things you may be interested in doing, given a matrix, is to try to describe particular scalars or elements within the individual matrix. And that is a process that's known as indexing. And it's something that we'll do when we get into the MATLAB lab for this week. But if you want to write by hand how you could index a particular element within a matrix, the way that it's traditionally done is with 2 subscripts. So if you look at this notation here, we have the variable name, which identifies the matrix, with 2 subscripts separated by a column. And traditionally, that first identifier will be the row number, and the second will be the column number. So if you think about m subscript 1, 2, what we're talking about there is the element in the first row and the second column. And in that case, this element would be 2. Versus the element m2, 1 would be the element in the second row and first column. And again, you remember you're always starting from the upper left-hand corner. So we'll go down to row 2, column 1. So that will be element 3. One thing you want to know is if someone were to ask you, for example, in this matrix to find the element in M3, 2 or something, if you can have answers where the element of a matrix doesn't actually exist, if you're being asked to index outside of the physical size of the matrix. So for example, since this only has 2 rows, if you're asked to find something in the third row, you would just say it doesn't exist. So what is a vector in this case? Well, a vector is nothing more than a one-dimensional matrix. It can either be a single row of numbers, or it can be a single column of numbers. Now, it happens in this case that I've shown you an example of a row and column vector that only contains 2 elements. However, they really can contain any number of elements. Particularly, a row vector will always have 1 row, but it can have n columns. A column vector will always have 1 column, but it could have m rows. So one thing that you want to know is if you're familiar with concepts of physics and you've heard of a vector as a physical quantity that's unambiguously described by a magnitude and direction, we'll see when we get to the lab on mechanical engineering that these 2 ideas are kind of related, but for now, just keep those 2 ideas separate. and know that a vector is nothing more than a matrix in one dimension, either a single row or a single column. So let's look at some example problems just to emphasize this. If I'm given this matrix A, I'm using the variable name to define it. I can tell it's a matrix because it's a bunch of numbers ordered in rows and columns inside these square brackets. If I want to find the size, I start in the upper left-hand corner. I count the rows, 1, 2, 3. I count the columns, 1, 2, 3. And the size of a matrix is nothing more than the number of rows, 3, by the number of columns, 3. So this is 3 by 3, with by written as an X. Element 2, 1, A2, 1, means go into row 2 in column 1, going down from the upper left-hand corner to row 2, going over to column 1. That value is just -2. A1, 2 is first row. Go over to the second column. That will just be 1. So second question here, consider the vector shown below. We notice this is a collection of numbers ranged into a single column. That by definition is a column vector, not a row vector. And we can size it the same way that we size matrices. Start in the upper left, count the number of rows, 1, 2, 3. Count the number of columns, just 1. So this is a 3 by 1 vector, which is not surprising since all vectors are just one-dimensional sizes or one-dimensional collections of matrices. So if you have any questions on that, feel free to reach out. Hopefully it was a little bit of review for you, and hopefully that first part served to motivate you as to why linear algebra is really important for engineers.